Well, greetings, everyone. We are the Engineering Concepts Executed Now group. My name is Malcolm Miller. I'm the digital hardware design and peripherals person.
My name is William Seymour. I am the analog hardware design and SMS text messaging person.
My name is Kevin Marshall. I'm the software developer specializing in Android.
Hello, everyone. My name is Isaac Veal. I am a software developer as well as a liaison.
And hello, my name is Brianna Gunn. I am serving as a systems engineer and the fire expert.
So our customer for this project is Health ATM. Our advisor is Dr. Doss, and our co-advisor is Dr. Graves.
The motivation for our project was want to have a unified system necessary for reporting to doctor's office or the offices. Less time filling out forms, keep all health information in one place rather than multiple areas and multiple locations. Our goal was to complete an Android app as well as a feature phone app, which would be SMS service.
So Health ATM's current practices, they use an online setup where the patients can go in and manually import their current states as far as their blood pressure and other health updates that are stored in the database. But the future of Health ATM is to use our apps and our technology to streamline the client-facing part of their business. In the current state of health records, they're using HL7, and they're trying to keep all the health records secure, and they're trying to integrate FHIR as another way to keep it secure.
So in our presentation today, we're going to talk about engineering requirement specification. We have some functional block diagrams, a UML diagram, a test document, work breakdown structure, a Gantt chart, and a cost summary table.
For our engineering requirement specifications, these are actually our marketing requirements. So I'm going to tell you a few of our specifications that relate to these. One of the things that we wanted to focus on was system will authenticate users. That's going to reference our security aspect as well as our accessibility. Another systems will be fault tolerant. That would be a security as well, along with reliability. But the one that, as a group, we decided would be the most important one that we was asked to highlight in our document would be system will work with various authorized healthcare products. The justification for that being that the main purpose, one of the main purposes for this program for the Android and SMS is that you want to be able to stay at home or wherever you may live and still grab data from multiple devices. So it kind of doesn't really make sense to make an app that's only going to work for maybe just a scale.
Next, we have a functional block diagram. As a group, we decided to use two devices as of right now. We're using an activity accelerometer as well as a digital weight scale. And as you can see here, the information will be collected via Bluetooth by a wireless Bluetooth receiver. And then that information, that data will be correlated as well as parsed and made available by a data file. That data file will also keep the information, will have the information available for a messaging controller. And the messaging controller is basically like a liaison between the healthcare provider and the patient to offer incentives as well as just to keep them, I guess, up to date with everything that's going on. The data file also makes the data received from the accelerometer and the weight scale available to a cloud, which basically stores all of a user's health, and it's basically a profile that's going to be created that holds all of that information, and that's going to be stored on the cloud. This information is also available to be uploaded to official public health records, as well as a health ATM kiosk, which may be set up in a doctor's office or a hospital, if you will.
Next, we have the UML activity diagram. We chose the UML activity diagram basically to explain how our system works, like the function diagram, just to explain each step. So first, you have the public health records, which are the health ATM kiosk, which is sent to the controller. And the data from Health ATM is put into a message. And the message is sent from the server and it's parsed into a data file. The data file is then sent to the user's mobile device, where they can say, hey, it's time for your checkup, or have you weighed yourself today? And that's where the user goes to their weight scale or their glucose meter or their accelerometer. And then once they take the information from those weight scales, it's sent to their mobile device through the receiver. And it's parsed into Bluetooth, and the mobile device sends the data to the server. From there, the server sends the data to the public health records in ATM, where it's stored into the public health records through SQL or the health ATM cables.
What type of diagram is that?
That's a UML activity diagram.
What do those dark rectangles represent?
Those represent the controllers. Like that one represents the controller, and then this one represents the actual user, like their phone or something. Their phone.
And the circles represent what?
The circle represents what the user's weight scale when they actually weigh themselves, and they send a message back.
Okay, so where you have the arrow coming from the last circle,
Mm-hmm.
and then it splits off into two places. What does that indicate?
It's indicating that it's going here first. It was kind of hard when you're making to make one arrow here. It's going here first, and then it's going back out. It's not splitting into two separate arrows. It goes here first, and then it goes back.
Okay, so what does the first circle represent?
The first circle,
Yeah, on the left side.
the first circle, that's the public health records, the whole server, the ATM, and everything. This is the public health records where the information is actually stored.
You say this is an activity?
Where they're at activity.
Okay. Yeah, you may want to check that. I mean, you're describing more of a signal, a flow, a data flow diagram, but that doesn't look like data flow either. But, yeah, I'm not sure what that is, to be honest. Check on that. You recognize what it is, Dr. Bell?
I'm not a UML person, so I wouldn't recognize either way. I looked at it 10 years, 12 years ago or so, it's been a while, so I wouldn't be able to critique one way or the other.
All right.
So for our test document, which is in our design review document that we turned in, we decided to go with a step-by-step document, which would basically be testing preliminary software, and the code will pull data from the healthcare server and be able to populate it. And once you pull the data, it'll be able to reflect those changes once you populated it. So that'll be for a demo at a later time. We also had a work breakdown structure, which is also in the design review documents. And the three main portions of the work breakdown structure were to create a program application, and in regards to that, you have to create the code, make it HL7 and FHIR compliant, and then also make the SMS service. And the second main part would be getting up peripherals, which would entail ordering them, receiving them, and testing them to make sure that they work as expected. And finally, would be the systems integration and tests, which would basically put the two together.
This is our Gantt chart, which is basically a detailed representation of our work breakdown structure. And we chose the start date as October 2nd, 2013, because that's when we officially chose our project. And the Gantt chart is breaking down each part of the work breakdown structure, depending on the duration of days we chose for when these different tasks will be completed. The Java code task is it starts first, as well as the SMS and the purchasing the peripherals, because those are separate of each other. You don't need to do one before you do the other. The compliance task is dependent on the Java code, and through all of these, our expected end date would be November 13th, 2013. Proposed end date. For integrated.
So this is our cost summary table, which details our peripherals that need to be bought, which would be the Fitbug Air, which is our accelerometer, and our wireless weight scale, both of which are Bluetooth enabled, and we had to make sure that we chose things that were within our $250 budget.
So the data, do they have documentation that lets you know what the actual data is? If you so you can parse out what's being sent, like the weight scale. Do you have some documentation so you know, okay, this is an actual weight measurement or what have you?
There is some. We haven't done all of the research stuff to see what their code is completely, and if it turns out that when we do more that it doesn't, then we'll choose something else. But for right now, as far as our budget goes, these were the best things that fit into
Kind of, I guess I'm not understanding. Are you're saying that you looked at the website and it seemed like they have documentation for being able to parse it out?
Yes.
Okay, but you won't know for sure until you actually get it.
Right.
Okay. All right. What about the Fitbug? Same thing?
Same.
So in conclusion, our project is centered upon improving the current health ATM model. It's currently only a web-only access type deal. So we want to develop an Android app and an SMS service to be able to better improve their current model and make it more accessible to users. And we'll do so by testing everything that we do. Any questions, comments, or concerns?
Well, since you said it, concerns. Well, for one, the Gantt chart, and I don't know, maybe I didn't make it clear. Maybe I did not make it clear. But that's supposed to be the entire project. So you're supposed to map out the entire project from now until the end of senior design too. So as soon as you can, I would like for you to do that, just for your own purpose. Because the Gantt chart is supposed to project what you're going to do, not tell what you did. All right. So the object was to, from now, map out the rest of the project. That way it's useful.
Are you saying from now or from everything we know up to this point and until senior design too?
Well, up until this point wouldn't hurt, but
Okay.
I'm more concerned about from where
now.
you are to where you're going to
Okay.
be. Yeah. So, how do y'all feel about where you are and where you're going?
I feel like we've come a long way from the first presentation. I feel like, I guess, technical wise, I feel like we've come a long way as far as from the proposal. There's a lot more knowledge gained, and we know a lot more about what we're talking about now.
I mean, I would pretty much agree. We know a little bit more about the scope of our project and what we're supposed to be working on. But in the beginning, we were still really lost.
All right, go to your block diagram. Why are those red marks? Well,
It's spelled correctly, but I think
I thought that presentation
What's that?
I
This
don't
is,
see why it's there, but it shouldn't be there.
anyway, that's my but
the Apple.
so where is the where would you say the analog design?
the analog component would definitely be the accelerometer. It's kind of a adjustment that we had to make throughout the project to incorporate the analog portion.
So from a health perspective, what is it? What's the accelerator? What's the purpose of the accelerometer? What is it?
Well,
What's
the
it measure?
accelerometer, as you know, measures activity. So I guess as a person moves about, maybe their house or as they go in and out of different places, exercising as well. It just kind of helps to monitor exactly what's going on to give a better diagnosis if they're having problems, or also to just keep an updated record of everything that they're going into.
Okay. So in terms of your project, what all are you going to be measuring in terms? I mean, from my understanding, an accelerometer will basically tell you, you move this way or move that way, or rotated this way or rotated that way. But what you have to do from that is you need to translate that into something useful. Okay, see, like this accelerometer in here will tell me that this phone is now this way, but I need to translate that into, let me orient the screen in a landscape fashion or a portrait fashion. How are you guys going to translate
that into
an activity level or into whatever you want to?
So let's say you use the same example as your phone. Your phone is going to, the readings for your accelerometer, your gyroscope, or anything like that, it's going to read differently as you walk versus you sitting down or it being not stable, stationary.
Okay.
So we can test whether or not a person is running. Let's say they use their weight scale, their Bluetooth-enabled weight scale, and through FIRE, the doctor recommends that you run 10 minutes 2 times a week or something like that. We can say through that accelerometer that during this repeated motion that we can test on our own, that the accelerometer is going to move this way if it's based on your hip or your hand or anything like that, and record that, still saying that this is what you should see, and then here's the duration of 10 minutes, and then still through the FIRE application, through the FIRE resources, pull that through, and the doctor can say, okay, well, I see that you're running 10 minutes 2 times a week. We can incorporate it that way. I mean, we're still trying to play around with it, but still trying to play around with it, but at this point, we're still trying to find, I guess, that sweet spot.
So I can see how, for the weight scale, I'm assuming it's going to transmit wireless data when you step on it, when you read the weight scale. So how often are you going? What's going to trigger the transmission of the accelerometer data to the receiver?
Again, that's part of the test we're saying to see if we're going to either incorporate it directly into a separate app or with the FIRE application. Some we're still playing around with.
All right, but just in your mind, what would make sense? Would you should do every minute?
We kind of wanted to do it like your phone, for example. If I wanted to send you maybe like a song or something via Bluetooth, you would obviously have to enable your Bluetooth receiver on your phone, and I'd have to do the same to actually transmit data back and forth. So we're thinking of a similar concept to incorporate within the accelerometer as well. Does that answer your question?
Not quite. Just think about a scheme. So, I mean, the simplest thing would be, do it periodically. Or, obviously, you have to be in range of the receiver in order for the transmit, right? So maybe every time you're in range of whatever the receiver is, maybe it updates the activity information. Or maybe every time you step on the scale, it also activates that. So just think of some, logical way to do that. And I'm not completely sure how analog, an accelerometer itself is an analog device, but it has it has analog output. So I guess you can squeeze some analog design out of it. So I guess in general, just my comment is, y'all gonna be here on for break, right? Y'all gonna be around for y'all not?
Around my house?
Maybe y'all can work through Skype or something.
Yeah, that's
what is it? Adobe. What's the other one? Adobe. What's the new thing?
That's not Adobe.
The Adobe.
Hangout?
That's Google.
Google Hangout?
No, there's an Adobe,
Adobe.
tool that allows you to work